Alright, time for another draftphysics.com, debatephysics.com also, video presentation. So, Ian Gosling has made a video, and I'm damn curious. So, he's going to try to argue that gravity isn't a time-dependent force. And he says his title, his version of that statement is Gravity Cannot Be Evaded. So I obviously agree that gravity can't be evaded in any sense that if you're in it for a period of time, you can't evade it while you're in it. But yes, you can evade being affected by it by getting it over with. So if you fly by a sun, for example, you fly by fast, you'll evade the substance of the gravitational force in the sense that it'll only be a small amount of force that'll affect you. And he's not going to be able to argue that argument. And especially using my own analogy of the rain thing, it's just no possible way this will work. But let's see him try.
I've had to leave the...
So he's using the rain analogy, so there's a gravitational field. Now obviously it would usually be spherical and it'd be going all directions like light, but you can understand that just like light, you can pass through a plane anywhere in space, and that plane will get an average amount of photons hitting it. And you're just basically saying, how do I evade the photons? Well, I run really fast and I'll evade the photons. Not that complicated. So let's see if this picture is adequate. Yes, that's centered enough.
The physical demonstrations today. I was engaged in a little addition to one of my plastic pendulum rods, Gary. They were plastic.
Regardless, they have mass, and they're completely changing the function of the pendulum because now the mass is spread over the whole pendulum. It's not in one location anymore. So it's a completely different experiment. It's not a 5 mass against a 10 mass. It's not a something going twice the speed versus because they're not the same. The mass is diluted by the mass of the plastic.
I was going to drill a hole in one of them and put some weights that would exactly double the weight of the pendulum rod to give it a counteract your unfair.
You can't do that. I mean, it depends on where you put the weight. So we're back to rotational momenta again. It's where the weight is located that's going to matter. The weight close to the fulcrum doesn't do much velocity at all. The mass further away does a very high velocity. You're just not following along here.
Advantage idea of the weight of the rod, you know. Anyway, the one with the 1 mass, I was gonna double its weight by adding weights to it. In so doing, I've broken the bloody thing. It's snapped.
Super. I didn't see where the fuck you're going with that crap anyway. Where the hell you going with it? It's as far from the ideal as you can get. So, you know, what the whole point is try to create the idealization. Try to get friction and all these other variables out of the experiment, not to complicate it further by creating variables that you don't want in the experiment. So I don't even know what the hell you're trying to do.
So it looks like I can't do any more pendulum collisions, which is... I was quite enjoying that.
It's really bad just because they were so inelastic. They were so bad at bouncing off of each other or keeping the energy in the objects that I don't know what possible use such collisions could do. It's like smashing butter against, maple syrup. You're really not going to see anything interesting.
Buy a bit more bloody pipe, I suppose, but keep spending money on these things. It's anyways.
Doesn't look like you're spending any money on anything. Sorry, it looks like crap you picked up off the, I haven't spent any, Well, I did spend $1.49 for some plastic things that really just didn't work out at all. Too cheap.
So I thought I'd just talk about this as there's some lack of understanding you have.
Whatever. fuck you. It's so stupid. I've spent much more time analyzing this shit than you have, by a long shot. So this is just such shit. You're such a shitty, stupid fuck to say something that's stupid. You're the one who was underappreciating the details. And show it. I mean, you can't even measure 4 times the height, for fuck's sake. Shit.
Or misunderstanding we have with each other. I'll be fair like that.
Yeah, that would have been better, but it's too late for that. You can't be fair after you've been unfair. That doesn't work.
About the arguments. Now this is going to be the planet, or the surface of the Earth, this line.
Who's playing these games, okay? We know the surface of the Earth for us is not round, it's not an issue, blah, blah, blah. So yes, it's just realistically a flat plane. Fine. It's just a distance from here to here. Okay? You don't have to complicate that in any way. And the simple argument is when you're moving through a force, if you travel that distance quickly, you'll evade the force.
I want to narrow down the misunderstandings. This is the surface of the Earth. And the body, whether it's a person moving...
So I never drew this. So instead of just redrawing what I drew, which was a planet, and you're going to fly by a certain line of distance, and all you're going to do is say, well, how do I change how much I get bent? Well, the faster I go, the less I get bent. Means that I encountered less force.
Moving, or whatever the object is going to be moving along.
I bet he's going to do something really stupid, like think the force moves at this like 5 miles an hour. We're talking about a force that's moving at the speed photons move. It's going the speed of light. Okay, most physicists understand that gravity moves the speed of light. That whatever effects it has, it does these effects at the speed of light. Most physicists would say if the sun disappeared, it would be 8 minutes before we would know about it, because we have to wait at the speed of light for the gravity to disappear.
Just above the surface of the Earth. Parallel to the surface of the Earth. Okay? I mean,
look, you know, this is just, I've drawn it so many fucking times, and here you are sitting there playing some game that you have to do this minutia bullshit. I mean, so I'm going to rub it right in your fucking goddamn face. This is just so fucking stupid. I mean, why do you have to make videos like this? What the fuck are you doing, you fucking idiot? I mean, it's just so obnoxious. Where the hell's the other camera? There it is. I have to move it over. I mean, this wasn't complicated at all. So I've drawn this at least, what, a dozen times now. A dozen fucking times. There's a gravitational body producing the gravitational field. Here is a line, point A to point fucking goddamn B. Alright, and all you're saying, all the argument is that the force does go this way. Whether you call it bent space, it doesn't matter what the fuck you call it. It's a force that tends to push things towards the object. So everybody agrees on that already, you fuckhead. This isn't complicated. And what you're supposed to dispute is that it doesn't have anything to do. This distance is the same amount of force hits you no matter how fast you go across this distance, or even how fast you go this distance. This moves the speed of light. This might move 500 miles an hour. Well, 500 miles an hour compared to the speed of light is about 1,000,000 times difference. Okay, so it just matters how long you're in the gravity. Whether you're going this way or whether you're going with the force, it doesn't make any difference. All that's going to matter is how long are you a freely moving body that is free to be pushed. As long as you're free to be pushed, all that's going to make any goddamn difference is how long were you in this differential. This differential where there's a big fucking pushing arrow going this way and there's a less sized arrow going this way. And that differential will push you, and it will push you based on how long you're free falling in it. That's the argument. Why do you need to make this any? Why is this baby talk crap? Okay. Why is it necessary? There's the point. Get to it already. Fucking cunt. Shit.
Establish that if this is a rain cloud, this rain area is localized over the...
That's silly. It's localized. We're talking about a distance, yes. Draw two buildings on either side, so there's no rain getting in. They're buildings. And you're going to run from one door to the other door. There's 50 feet of space you have to run. The fact is how wet you're going to get is going to be dependent on how fast you walk. You take an hour to go, you're going to be sopping wet. You take 5 minutes, you get a little wet. You take 0.3 seconds, you don't hardly get wet at all.
This space, isn't it? This distance, which you can measure, and put a figure to it. Now it's quite clear, the faster you move through it, this is the example you're giving, whether it's rain or radiation coming out of a window
or light, yeah, and you're getting a sunburn. How long you're in the photon stream will decide how sunburned you get. Yeah, over it and over it. Get to your counter theory.
The faster we go through, the less rain would hit you, I would think.
The Mythbusters actually did that experiment, okay? I mean, they did it kind of shoddy, fire hoses and blah, blah, blah. Just because they were thinking about how much rain you run into. The rain that's already falling and you're running into it. So, obviously, the analogy breaks down if you pretend that photons moving the speed of light, that you can run into them in any substantial way. Like it's going to make a much difference. The photons you hit sideways, no. The fact is there's a certain amount of them that are hitting you from above, okay, in the time you're traversing. Those are the ones we're really talking about.
I think we could agree on that.
Then it's over. Thank you.
But this is not applicable. This is what I've been trying to say. This is not gravity, is it?
No, it perfectly duplicates what gravity does. Perfectly, okay? You'll find no circumstance where this analogy fails to explain the phenomenon. There's no experiment ever conducted in the history of mankind where this simple explanation fails to provide a perfectly satisfactory description of the circumstance. So that's what I'm asking you to do, is show where this analogy fails. So show a circumstance where this analogy fails.
I've represented gravity as towards the surface of the Earth in honor of you, Gary.
Go fuck yourself.
So this is constant as we move across the surface of the Earth.
But whatever that means, this is constant. Yeah, there's a constant amount falling, and the question is, how long are you exposed to the constant amount? Period.
The same as we did here. Don't confuse matters. We're saying...
No, I didn't confuse anything, you fuck. I've tried to make this as simple as possible. Confuse matters? Where did I confuse anything, fucktard? I mean, it's so goddamn simple.
Staying at the same height. We're not going against gravity or with gravity.
No, I drew a straight fucking line, point A to point B, over and over and over again. So again, what are you talking about this shit? I didn't move any lines anywhere. I didn't do any bending of the lines. I said a constant force. Okay, yes, you're not quite as close at these circumstances, but that all equals out in the end, and there's an average amount of gravitational force.
Up or down.
Fuck.
We're staying parallel to the surface of the Earth. So the force now of gravity is constant as we move through it. Now, this example, the faster we move, we've moved from outside of the rain to inside of the rain, getting wet, to outside of the rain again.
What a retard. It doesn't matter. We're talking about the distance you're running right there. You can make the distance further, you can make the distance less. It doesn't matter. It doesn't change anything at all.
And you could say, yes, the faster we go through slow, the rain is hitting us. If we stop still, we're going to get very wet. Or if we go really...
Yes. Again, and it's all about the fact that you're free falling, that the force can act on you because there's nothing else stopping you. You're not holding on to something. It's a stream. The stream will push you, whether you like it or not. If there's no anchor, if there's no rocks, if there's no anything for you to grab hold of, the stream is going to push you at a rate. Period. And it's just going to matter how far downstream you are. Is just going to make the only thing that's going to matter is how long you're in the fucking water.
Quick. We won't get very wet at all. Now, does that apply to gravity? Moving through the gravity?
Of course it does. Every single experiment proves that it does. That's the whole point of launching things off of cliffs, is to point out the fact that it falls at exactly the same rate. That the two things, the thing that falls straight down hits the ground at exactly the same time as the thing going across the gravity. Because they absorb the same amount of gravitational force. Oh, Jesus. The thing going very fast is going longer distance. So high speed, longer distance, same exact amount of rain.
I don't believe it does.
Well, then you're stupid. Well, we already knew that. So he's drawing a line. I'll just pretend speed doesn't have anything to do with what you're talking about. You have to draw the line fast, or you have to draw the line slow, idiot. You don't have any velocity in your drawing. Okay, you have to put velocity in it, idiot.
I don't believe it does. For one thing, we're not moving from an area outside of the gravity to inside.
It doesn't matter. We're just talking about how much force you collected going from point A to point B. It doesn't matter whether you have a point C, D, E, F, or G. The same rules will apply. Fuckhead.
The gravity to outside again, as we did with the rain example. We're constantly in the force of gravity.
Whatever that means, you're constantly in it. Okay, so here's something. I'm going to launch this off a cliff. It's constantly in the force of gravity. Is it falling? No, it's on the cliff, you shit for brain. It's not collecting anything. It's just not collecting any velocity in this direction, is it? Is it free falling? No, it's completely supported by the cliff. So why would I sit there and say, well, it's collecting the same amount of gravity as if there was something sitting on the cliff? Yes, of course, it's the same amount of gravity as something sitting on the cliff. They're both collecting the same gravity. Now, push them off. Free falling. Just this thing's dropping and the other thing is moving this way. What's happening to the thing moving this way? All right, it's all in the same force. The same force is hitting it. Doesn't matter where it goes. The same force is hitting it. The same number of photons are hitting this thing as are hitting this thing. They're both getting hit by the same number of photons. This one isn't getting hit by less. No matter where it goes, it's just as light. It doesn't get darker anywhere. It's the same amount of light. They both get pushed by the same amount of light. So even though this is going faster and it's doing lots of other stuff, it doesn't matter. It's getting hit by the same number of photons. Fuckhead. Oh, what an idiot.
Aren't we? Constantly. Now you say, as we move quicker, less gravity affects us.
Yes, if you weren't falling in the gravity, that's how it would work. If you were going from a set amount of distance. So just have something go very slowly through the gravity and have something go very fast through the gravity and allow them to continue to free fall, and you'll see a difference.
Thinking of the example of the rain, there'd be less droplets of rain to hit us. I don't think this is true.
Well, saying you don't think it's true doesn't really add up to anything. So you're saying I'm going to get more sunburned if I shoot off really fast and I travel a huge amount of distance this way. It's going to change how much force is pushing me this way for the amount of time I'm in it. I mean, that's what we're talking about, is the total time you're in it. how else to say this? You can't have them in the gravity the same amount of time. There has to be an ability to get to the point B where you're going to end the experiment. If something can't get to point B, then yes, they're going to get just as wet as each other, but they're both just going to hit the surface, and that's the end of the experiment. The whole idea is you're going to actually get to a point B. You're going to get to a finite point, and you're going to go a speed that'll get you through this distance, okay, faster or slower. Anyway, I just can't believe you could break such a simple analogy. Like I said, you can think of it as being sunburned, or you can think about it as being getting wet. And the simple, I mean, it's just such a simple argument. If all there is sun here to here, that's the part that's sunny, and there's a building here and a building here, and there's no sun, and I go through the sun quicker, I got hit by less sun, I'm less tan. And the slower I go through, the more tan I'm going to be. I mean, how can he mess that up? Well, he just did.
And I think physics says this is not true. In actual fact, if I had to guess, using my intuition, I would say that if this was rain now, I know I said this was gravity, but imagine this is the rain, and it's a cloud that's many, many kilometers.
I know, there's no point. You have two things that never get to point B. So what's the point? You're just saying I'm just going to push two things, and they never, there's no end except when they crash into the earth. So you're just saying, well, one of them takes longer to crash into the earth. Yeah. So it didn't accomplish anything. And it won't take it if it's a flat line. If the earth is a flat surface, then they're going to hit the surface at the same time. You haven't allowed the velocity to mean anything
Over the surface of the earth. So we can't avoid the rain.
It's like having this cloud analogy, and you just say the two people, both of them will not leave being under the cloud. So neither one of them successfully get to the other side. Yeah, well then they're going to get hit with the same amount of rain because they're both in the rain the same amount of time. If nobody can ever get out of the rain, then yes, they're both going to get equally wet.
I would say, using my intuition, that the faster I ran, the more wet I would get. Now that might seem controversial.
No, it might seem stupid. That's how it seems to me, stupid, yeah. Sorry. You're evading as much as you're running into. So for every raindrop you run into, you missed one that would have hit you. You could argue. So it's not going to make any difference.
But I don't think it makes a difference. You don't get less wet. Because the faster you run, you'll actually, whatever droplets you might avoid here, you're running into them here. And
yeah, so you just debunked your own theory. Great.
Faster you run in a second, you cover more distance. So in actual fact, you're running into more rain over that distance.
So again, you're just sort of breaking the whole thing, right? You're not going to run into more photons. So if you understand it to be light, you'd understand I can't really run into more light. Somebody's shining a flashlight horizontal, tangential to my perpendicular to the direction I'm moving. I obviously can't run into the photons.
It's possible you would get wetter the faster you ran. You'd be running into the rain would become a vertical sheet, almost stopping in time, and you'd be running straight into it.
It's always going to be a fixed amount, again based on time. You just keep ignoring the time argument. If you walk slower, you're also walking into the sheet. The same sheet is in front of you. There's no different sheet of rain in front of you. It's the same sheet of rain. Going through more sheets doesn't change the fact that you have to go through the sheet, so to speak. It doesn't change it. Every second, every millisecond, there's a sheet of rain in front of you. So no matter what speed you're going through sheets of rain.
Face on. Perpendicular to the rain. But anyway, it doesn't get less. You don't collect less by moving faster through it.
Yeah, you do. It's just a fact. So what you're saying is wrong. You do collect less by going faster if, and only if, you understand that there's a real field that you're going through. If you're just going to say we're both going to stay in the field, it's not a time dependent field, you're going to be in the field the same amount of time regardless of how fast you go. If you're making the Earth an infinite plane or something and there's no point B, right? If I start from point A and there's no point B, yeah, it doesn't matter how fast you're going because you're both going to be in the rain the same amount of time. You have to have an exit point. If you don't have an exit point to get to, then there's no point in the analogy. But frankly, it's still just a factual truth that you're going to get bent in different orbits. So if we make it back into an orbital argument, there's just a simple fact that it'll demonstrate you're going to be in a different orbit depending on how fast you go. I mean, it's going to change if something drops straight down, obviously there's a very straight line down, right? And then it curves more and it curves more and it curves more. It's a bigger and bigger circle the further you can go. So the faster you're going, the difference will be you'll see some difference. It's the same force, but it's going to be applied over it's the same amount of force in the same amount of time, but it's applied in, I don't know how to even describe it, different increments over a broader distance, and that will change your orbit. Won't change how much velocity you have. You have the same velocity. Your orbital velocity will be the same.
The point is, this example of the shower cloud is wrong because it's...
I just can't stand you. You're just such an asshole. There's absolutely nothing wrong with it. It perfectly describes how things get into orbits and how things miss orbits. It's perfectly coherent. All right? You're just fucking it up as an argument to play your silly word games. All right? I mean, it's just a fact that the gravity in free fall, it's just about how long you're in the force. You're making an analogy to something where both objects are in the force the same amount of time. Yes, if both objects are in the force the same amount of time, they'll be affected the same. Duh! That's not the argument. Shit. Fucking idiot.
Over a limited space, where the gravity, as we move along the surface of the Earth, is spread out continually. And the rain cloud analogy...
So they're both in the force the same exact amount of time. Therefore, they collect the same push. Therefore, they hit the ground at the same time. Yeah, I've already been over that. Shooting things off cliffs. That's not the analogy.
Is similar to this analogy you often give of a planet and in a spacecraft here.
There's my drawing. Now take this drawing and put a point A and a point B on the line, and then explain how going across that field of gravity at a higher speed won't mean you got less push. But of course it will mean exactly that. Again, even if you move it even if you're going in the same direction as the gravity is moving the speed of light. You're not going to outrun it.
Moving past the surface of the Earth, this is similar to the rain cloud because we're moving here where there is no gravity.
Oh yes, there's less and less and less, diminishing. And it doesn't matter. Again, we're just saying here's a length, a distance. The amount of work gravity will do isn't dependent on that distance. It's dependent on how much time you're in the force.
Very little. We're much further away from the surface, and we're moving into the gravity where it's maximum, and then we're moving out of the gravity again. So you could say, yes, the faster you move past the Earth, the less that gravity would affect you.
Yes, that's exactly the point. That means it's a time-dependent force. How much time you're in the field of the gravity will decide how much the gravity can push you. So if you have two equally massed objects, that is, they have equal surface to be suntanned, the longer you're in the force, the more tan you get. The less you're in the force, the less tan you get. Duh. That's the simple argument. It always works. It's how the universe works. Frankly, gravity is a time-dependent force. It doesn't care about distances. It cares about time. Time is the cause of the effect. Distance isn't the cause of the effect. Distance is a symptom of you taking less time. You have to go a faster velocity. It's just a symptom. The elemental cause is the time element. That's the contention that you have to refute.
But as I say, that's not applicable to moving along.
Oh, fuck you. It is applicable because, again, you're just cheating the experiment by saying both objects are going to be in the same amount of time. No matter how fast they go, they're going to be in the rain. They never get out of the rain. That's not the scenario. That's not how gravity works. When something's flying by in gravity, the point is that, yes, there's going to be places where the gravity is very strong and places where the gravity is very weak. The field changes.
Surface of the Earth parallel to the surface.
Again, and for the same amount of time. You're not having, there's no building here, there's no end to the rain cloud, you're saying. Well, if there's no end to the rain cloud, then both things get equally wet because both of them are getting rained on the same amount of time. So you've just completely broken the analogy. I mean, just said fuck you to it.
Because the gravity never gets weaker or stronger, does it?
It doesn't matter whether it's weaker or stronger. Again, if you make it a constant magnetic field, it doesn't matter. The point is the faster you go through the field, the less you'll be affected by the field. And you keep just evading that simple actual fact. So again, you're just demonstrating that you're not just stupid, you're belligerently stupid, because this is just stupid. To try to sit there and contrive a way of saying that gravity isn't a time-dependent force is just showing your desperation. You know you can't concede it because, well, if you concede that, then you have to concede that something doesn't get 4 times the energy because it falls 4 times the distance. Just like in the friction argument, you don't want to have to concede that the only reason why the twice as fast thing rolls 4 times as far is because the friction isn't linear. You just can't concede because, yes, you know, logically that means your theory's in trouble. But it's just an absolute fact, frankly. You're collecting the force based on how long you're in the force. The field affects you based on how long you're in the field, the differential of the field. It's true of magnetism, it's true of electric fields, it's true of, well, such as they are, it's true of photons. Photons are just behaving exactly like gravity in reverse, okay? They're pushers instead of pullers. But it's the same damn thing. Same rules.
It's a uniform field. A uniform field, Gary.
Again, that you never escape, so there's no point in having the conversation because no matter how fast I go, I'm still in the gravity. I never get out of the gravity, so therefore I'm still getting rained on the same amount of time. So it doesn't matter how fast I go because I never get to leave the rain. Duh. I mean, fucking duh.
I want to be clear about these aspects of what we're arguing because it seems to be a problem.
Yeah, the problem is your brain doesn't work very well. Alright, this is such a simple thing. Again, how long are you in the sun? How long are you in the rain? It always answers the question. All you have to do is ask, how long did these little lines hit you? And you'll know how much the little lines pushed you or gave you skin cancer. I mean, it always works. And here you are playing a preposterous, stupid, moronic game saying somehow, you know, because I'm not going to allow them to leave the rain. So I'm going to let one guy can go up and he's flying in a kite and he goes over here and he goes over there and he goes over here and he goes over here. And the other guy just stands here, right here in the rain. And it's no big surprise that they're both equally wet. Yeah, because they're both in the same rain. What an asshole. Okay, so enough said. It's about time. Time.
What do you think of that? That's an honest argument.
Oh, it's not honest at all. It's just such a pile of shit. You know. Have somebody stand in the rain 1 second, then have somebody walk out in the rain and stand there for 2 seconds. Now they're going to get a different amount of wet. But you have to have some difference in the time they're in the forest. If you make both of them in the forest the same amount of time, yes, they'll be equally wet. But if you allow them to be in the forest a different amount of time, they will be differently wetted or differently tanned. That's the argument, and that's the one you completely evaded with this, I'll just make an endless line so they're never out of the rain. And they're both forced to be in the rain the same exact amount of time. Because I'll create an analogy where it's not like they stepped out into the rain and then stepped back in. I'll create a circumstance where they're forced to be in the rain the same amount of time. Yes, if they're in the rain the same amount of time, then they'll be equally affected by the rain. Okay, there. Yes, I concede that argument. And in every experiment where you're changing the amount of time they're in the force by changing their velocity, in every one of those circumstances, they will be affected differently based on velocity. Oh, God, what an asshole. Ugh. I thought it was going to be bad. I just didn't think it would be. Well, there was no. I thought it would be bad, and it was just plainly bad. I mean, I thought he'd, like I said, I thought the thing that would hang him is he would start talking about how fast raindrops move, and I'd have to explain. Now we're talking about a force moving the speed of light. Okay, so the speed of the raindrops doesn't have anything to do with it. There's no outrunning them. There's no of that nonsense. Okay. It's not an issue, not part of the subject. The stream is rushing, millions of miles an hour, and you can't swim against it, or you can't paddle, you can't do anything to change how much it's going to push you. But that's what I thought he'd do. But he did something even dumber, which is say, I'm going to make velocity irrelevant by saying they can never escape being in the force the same amount of time. So no matter how fast they're going, they're in the force the same amount of time. Yeah, so he cheated that way instead. Damn, I just hate this planet. So this is another waste of, I really should have watched the video first. I just thought it would be interesting to play it, but I should have just watched it first, and then I could have just made a 5-minute video and just said, gee, what a dumb argument.